Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, we are going to learn about polynuclear hydrocarbon. In this video, I will talk with concept about polynuclear hydrocarbon. So, types of polynuclear hydrocarbon. There are two main types of polynuclear hydrocarbon. The rings are isolated and the rings are fused together in the ortho position. Examples of isolated system: diphenylmethane, triphenylmethane. And rings are fused together in the ortho position. Examples are naphthalene, anthracene, and phenanthrene. Now, look at the structure of polynuclear aromatic. Structure of naphthalene, structure of anthracene, and structure of phenanthrene. Now, look at the structure of naphthalene and numbering scheme in naphthalene. Now, molecular orbital diagram of benzene and naphthalene. So all 10 carbons are sp2 hybridized. There are 10 carbon, so all 10 carbons are sp2 hybridized. Overlap of sp2 with s orbitals of 8 hydrogen atom. All carbon and hydrogen lying in one plane. That is also very important point. It is confirmed by X-ray diffraction studies. How you know the structure? You should know by the help of X-ray diffraction. It is aromatic, satisfied the Haeckel's rules, and it is less aromatic than benzene. Now, naphthalene nomenclature. Monosubstitution alpha or beta. 2 position is beta, 1 position is alpha. A special name alpha naphthol, alpha naphthylamine, and other examples. Now, naphthalene. It is the largest constituent of coal tar. It is obtained by cooling middle and heavy oil. The crude naphthalene is melted and treated with sulfuric acid to remove basic impurities, washed with water, treated with aqueous sodium hydroxide to remove acidic impurities, and finally naphthalene is distilled to give pure product. Now, resonance hybrid of naphthalene. You can see the three structure. Structure of naphthalene. So Erlenmeyer proposed the symmetrical formula of naphthalene in 1866. Gravy proved that it did consist of two benzene rings fused together in the ortho position. So naphthalene on oxidation gives phthalic acid. When nitrated naphthalene gives nitronaphthalene, which on oxidation gave orthonitrophthalic acid, this indicates the nitro groups is in benzene ring and other in the side chain which are oxidized. So nitronaphthalene reduced give aminonaphthalene oxidized phthalic acid was obtained, and amino groups attached to the nucleus renders sensitivity to oxidations. Now inference, benzene ring in phthalic acid obtained by oxidation of aminonaphthalene is not the same ring as that originally containing nitro group in nitronaphthalene. So naphthalene contains two benzene rings. You can see here there are two products. Now synthesis of naphthalene. When 4-phenyl-butene is passed over red-hot calcium oxide, naphthalene is formed. When 4-phenyl-butyrenoic acid is heated, a naphthol is formed, and this on a distillation with zinc dust gives naphthalene. Look at the reaction scheme. Now, orthoxylene bromide combined with the disodium ethane tetracarboxylic ester when refluxed in acid solution gives tetrahydronaphthalene dicarboxylic acid. When the silver salt of this acid is heated, naphthalene is formed. Look at here reaction scheme. Howard synthesis reaction scheme we can see. Now position of double bond in naphthalene. You can see the 3D structure. There are one rule, that rule is Fry's rule. Fry's compare the double bond present in polynuclear compound with benzoquinone. Structure 2 and 3 have a structure similar to the benzoquinone. Quinones are reactive than pure aromatic compound. Fry's believe that a stable form of polynuclear compound did not have with this quinone structure. So the most stable form of polynuclear aromatic compound is that form which has maximum double number of benzenoid ring and 3 double bond in each individual ring. So according to Fry's, naphthalene has a structure 1 has 2 benzenoid ring and not the structure of 2 and 3 has 1 benzenoid ring. Now reaction of naphthalene. The number of reduced product depends on the reducing agent used. If sodium in ethanol is used, it gives 1,4-diene, melting point. So you can see when reduced with the isopentanol, it forms tetraline, and tetraline is as vernicious. When naphthalene is reduced in the presence of nickel, it forms tetraline, then it gives decaline. Naphthalene gets oxidized in the presence of sulfuric acid, vanadium pentoxide, mercuric sulfate, or air to phthalic anhydride. So naphthalene on oxidation in presence of permanganate gives phthalic acid. Naphthalene on ozonolysis yield phthalaldehyde, you can see. Now ozonolysis, monoozonide and carbonyl oxide. Now substitution product of naphthalene. Orientation in naphthalene nucleus is more complicated than benzene nucleus due to presence of two rings in form. First group always enter the first position except the two cases when second derivative is the main product. Sulfonation at higher temperature, Federal-Graf reaction. Now introduction of second substitution can give rise to homonuclear substitution, substitution in the same ring, or heteronuclear substitution, second in the another. Friends, when chlorine, bromine, OH, methyl, these one position homonuclear substitution take place mainly in position 4 and 2 laser exchange. In the same way, one position, then sulfonation occurs at 6th position, and like that. So homonuclear substitution occurs only when the group already presents in ortho position. Now self-polarizability is greater at position 1 than in position 2 in case of naphthalene. So self-polarizability position and larger magnitude of self-polarizability, the more reactive will be that point for the electrophilic reagent. So pi electron density is greater in 1 into 2 than 2 into 3. Therefore, former will be more reactive than later. Now Federal-Graf reaction. Naphthalene nucleus is attacked by aluminum chloride when vigorous conditions are used. The low temperature is maintained to carry out the Federal-Graf reaction. Introductions of acyl group in presence of aluminum chloride gives 1,2 ketones. The nature of the solvent affects the yield. Now acetyl chloride is carbon disulfide gives compound 1 and 2 in the ratio 3:1, and with the nitrobenzene it is 1:9. Now you can see the reaction scheme. Chloromethylations of naphthalene, paraformaldehyde, HCl, phosphoric acid, and glacial acetic acid. You can see the reactions. Two halogenonaphthalines are conveniently prepared from 2-naphthylamine by diazotization. Look at the here reaction scheme. How NH2 converted into diazonium salt and then chlorine. Now, nitronaphthalene. You know, nitric acid attack naphthalene at room temperature to form one nitronaphthalene. Nitration of naphthalene at higher temperature gives mixture of 1,5 and 1,8 dinitroderivatives, and 2-nitronaphthalene is prepared by heating 2-naphthalene diazonium fluoride with sodium nitrite and copper powder. Now you can see the naphthalene sulfonic acid, how you will synthesize. When naphthalene is treated with concentrated sulfuric acid at 40 degrees Celsius, give the one derivative, and 160 degrees Celsius give the second derivative. You know, the beta-naphthalene sulfonic acid is the starting material for all beta-naphthalene derivative. Now you can see the reaction scheme formation now. Now uses of naphthalene, you can see there are a lot of applications like vitamin K, antifungals, the use of naphthalene. So LB reaction, LB synthesis, you can see how you will synthesize the anthracene. Now reactions of naphthalene, you know the colorless crystals, melting point at 80 degrees Celsius, boiling point. So these are the reactions of the naphthalene, nitrosulfonation in different conditions and chlorine. Now you can see the acylations. You can see the brominations. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.